magnetic front flow that connects from NPCM-2024. Hello. Magnetic first flow, my colleague from UGC and also colleague from BARC and students and participants. You have seen for last 2.5 days, you have gone through a lot of theory. So I have collection of some experiments which basically prove the basic principles of physics. And not only I showed to, as it is told, that I showed to schools and colleges, but I'm sure that you will also enjoy it. So without wasting much time, because I have been given only 45 minutes, so hopefully I have many more, but I will try to be in time. So let us see. And some of you might have seen this. This is called plasma discharge flow. And as I told, for each of these topics, there is a separate division in BARC. So in this topic, if you want to discuss in detail, it will take some time. But I will just show you the beauty of it. See, you will find there are sparks coming out, and those sparks are in all directions. This is called single electrode
projector.
This is single electrode discharge, and it was proposed by Nikola Tesla. If you see, if I take a tube light here, it glows, and many times magicians show it like a magic. But actually, why this tube glows? That is the very interesting part. I will show you. If I bring tester close to this, you will see it also lights. That means we are afraid that there must be very high voltage, and of course there is high voltage, but current is very low. And why that discharge is coming? Because this, if I touch this, you will find it will concentrate to my wherever I touch. Because this particular globe, there is a vacuum, and inert gases like helium or argon or their mixtures are mixed in this, and voltage is very high. I mean about 10 to 20 kilovolts, and frequency is also very high. It's 20 to 40 kilohertz. So because of that, it radiates electromagnetic radiation. And those electromagnetic radiation causes the discharge. And this is plasma, which is the ionic state of matter. This is the fourth state of matter. And if you bring the, even if you do not touch the metal part, then also it will glow because it is getting excitation or energy from this electrode. If you can see, I have pen with just neon bulb that also glows here. This is because when I bring this tube close to this, it gives some electromagnetic radiation to this tube, and inside there is a mercury vapor. And those mercury vapors will get excited. Mercury, the electrons in the outer orbit will go to the, they will jump to the higher orbit, but they are not stable there. So when they come down, they will radiate some, or they will lose some energy, and that will be in the form of photons or ultraviolet rays. And that ultraviolet we cannot see. So whatever the powder, what we see, that white powder, that works as a fluorescent material, and that gives you the light. That is how actually magicians show this, but actually there is no magic, it is totally physics. Here I have liquid nitrogen. I just wanted to show certain things. But before I do that, as you know, it's most of students and even people are familiar with this. But when you put some balloon, you will find that they will shrink. But what is the what you can prove with this? That is more important. See, when you say that when you hit something, it expands, and opposite of that, when you cool something, it will contract. But if I just take it out, you will find it will again expand. But with this, you are proving the Charles law, which we have learned in our 11th or 12th, because when pressure remains constant, the volume of given mass of gas is directly proportional to the temperature. So when temperature decreases, volume also decreases. So that is what we are, and this you can perform with in your fridge also, or if you have ice with ice also, you can see again it is expanding because pressure is same but temperature is changing. Same thing when you come out with this, when there is a Charles law, there is another law called Boyle's law, and it states that when temperature is constant, the volume of given mass of gas is inversely proportional to the pressure. So I have a balloon here, and it is inflated little bit. Now, when I push or pull this plunger, you will find that it inflates because pressure is going down, so volume is increasing. Very simple demonstration, but when we just write on this blackboard, students do not understand. But with this, and this costs nothing actually. It's available nowadays very easily. Here I have a transformer. There's a copper coil. It's basically inductor, and when I apply AC voltage, you just see it jumps. And all of you know that aluminum material is paramagnetic, and this is also actually, this becomes an electromagnet. And as it is AC, its field is changing at 50 times in a second. And because of that, you know Faraday's law, whenever there is change in magnetic flux associated with EMF is generated, and Lenz's law said it opposes to the original state, so it jumps. So the further, if you have suppose a ring like this, and again deliberately I have put the paper, otherwise it goes anywhere. Okay. Now if I cool this, you will find that, as you may be knowing, that it is because of eddy currents. So when I cool down, the conductivity of material increases or decreases? It will decrease or increase? Conductivity, I am saying. Resistivity? Huh?
Decrease.
I am asking conductivity, not resistivity. Resistivity will decrease or increase? Resistivity will decrease, so conductivity will increase. Let us see. Now I am putting same ring again. Just see. It goes much higher because that it becomes more conductor. It becomes conductivity increases. Just to prove that it is because of lenses or it is because of eddy current. Here I have another ring which has a cut here. So because of that, the circuit won't be complete. So if I put it here, and even if I apply, it will not jump because it's not completing the circuit. And same thing you can use for demonstrating the principle of transformer. And basically transformer is based on, again, Faraday's law of induction. You can see here, if I bring down this, it will glow. And again you can show different things. If you change the number of turns of this coil, if you change the standard wire gauge of this, so how it changes, all those things you can verify or demonstrate with this. There's another very interesting demonstration. There is some what is called effect. It's called Seebeck effect. So when you keep two different dissimilar metals and their junctions are kept at different temperatures, EMF is generated. And normally, at least I have not seen it shown anywhere, but it is already taught on our blackboard, and we also believe that it works. So I'm going to demonstrate that. So just to see, there is something called Peltier, which is the opposite of that. So what I have done, I have taken this that for the Peltier, if you give voltage, the one surface will get heated and another surface will get temperature will decrease. So I have used it in a opposite fashion. So if I cool this, you can see here, I have a motor and one surface I am going to dip in cold water, hot water, and another I am going to put in liquid nitrogen. So it will take some time because it has to, that aluminum part has to go to that temperature. Once it attains that temperature gradient, then it will start, you see, it started finished. Because so another demonstration is again a very simple thing. I have a container. I'm just closing it. Just see. It starts spinning. The question is why it starts spinning. There are two holes which are projected diagonally opposite to each other, and I'll recharge it again. See, for rotation or spinning of any object, you need to have torque, and torque is nothing but two forces in opposite direction. So when I put it in a water which is at room temperature, it starts boiling very fast, and because of that, conversion from liquid state to gases is faster. So when it comes out from one direction, as a reaction, that is action, and as a reaction, it starts spinning in opposite direction. And this is again proof of Newton's third law: action is equal, action and reaction are equal and opposite, and also how torque is formed. See, here I have a special, actually it is a showpiece. If I hold it in my hand, you'll find it's made up of glass, but just because of my body temperature, it starts rising up. It's not water. Actually, it is a highly volatile liquid, and my body temperature is enough for vaporization. But it is closed, and there is a partial vacuum here. So when I hold it like here, it will again go back because of this temperature gradient, it will again go back. Now what I will do, I will just use the same cold water here, and if I put, instead of holding it at bottom, if I just put it here, you see what happens. Immediately it starts coming up. Now the question is why it comes up. Answer is very simple actually. See, this contains some vapors of that liquid. So when you put some cold water or liquid nitrogen, they get condensed and there is a drop of pressure. So it sucks that liquid up and that's why that liquid comes up. This is called actually hand boiler. Some people at commercial it's called love thermometer. See, it is still working. Now, I have another demonstration. Here I have a step-down transformer and there is some unit, electronic unit. When I just connect it to this, you will find different color LEDs are there. And normally we are told that if you put any circuit in water, that will short circuit and it will not work. But this particular circuit, when we put it in water, you will find I just keep it here. See, immediately you will realize what I did, and I will tell the reason for that also. See, immediately this water start boiling. Which is boiling means the temperature must be 100 or 100 plus. But with my willpower, of course, Jaguar or magicians told some different thing. But my willpower, I can put my hand in boiling water and take it out. Okay, so that is possible. So I just request one of our students. So just come forward and just anybody please. And you have to have your willpower and put your hand in this boiling water and take it out. So he very comfortably take it out. Okay. Now the question is, thank you. The question is, why, although it is boiling, but still he could put his hands very comfortably. Why? Although it appears that it is boiling, it's not boiling. Actually, this circuit is called ultrasonic atomizer. It is, there is a circuit inside and it vibrates with very high frequency, which is about 20 kilohertz. And because of that, the water which comes across it, it's converted into very tiny droplets. If you observe very carefully, you will find that vapor which is generated, it's not going up. It's like a cloud. And if you are most of you are physicists, no? So generally, water is transparent, no? And vapor also is transparent, but you can find this is little cloudy. Now you can tell me what is the reason. You see, the scattering point of view, you can meet me sometime later and tell me what could be the reason. This is again ultrasonic atomizer, but magicians show it different way that they can put the hands in boiling water and all that blah blah blah. Okay. this is one of my favorite demonstration. See, we are taught that yesterday Negi sir was talking about total internal reflection. Huh? So when light passes from one medium to another medium, I think I should stop this. It is disturbing me. We have learned that when light goes from one medium to other medium, it bends, and how it will bend, that is decided by the optical density of that material. Here I have a circular scale, and this circular container I have put half, I have filled half with water, and there is the arrangement is such that when I pass this laser, it will go through center only, means I can rotate around the circle. See, now if I pass it through 0, it will go straight. That means we know there is something called Snell's law. What is Snell's law? So how much is the density, how much is the refractive index of this material? If it is giving 0 to 0, sin of 0 upon sin of 0, how much is it? Huh? For 0 angle, Snell's law is not valid. Okay. Now, if I move it, you will find, if I go to 10 degrees, the angle of refraction will be about 12 degrees. If I move 20 degrees, it is about 27 degrees. So, like that, you can show that it's not linear. And the other thing is, when light moves from denser medium to rarer medium, it goes away from the normal. That you can verify. Then, you can go like this, and you can keep on noting that at particular angle, you will find that angle of refraction becomes 90 degree, and that particular angle is called critical angle, and beyond that, this water-air interface works as an ideal mirror. That is why it is called total internal reflection. In fact, if you see carefully, there is a reflection prior to that also, but that is not total. That is partial internal reflection. And after that, actually, this interface works as a mirror. See, almost most of us, and including me, that we have learned that there is a law of reflection. It's a that incidence angle is equal to angle of reflection. Angle of incidence is equal to angle of reflection. But there are two more laws of reflection which are generally people don't bother about that. And with this simple demonstration, I tell those two laws also. See, here you have, you can see, if you change the angle, you can see the angle of incidence equal to angle of reflection. Second law is incident ray and reflected ray are on the opposite side of the normal. This is normal. This is normal to this mirror. So they are opposite side. And third and very important is incident ray, reflected ray and normal, they are in same plane. If they are not in same plane, this law of reflection will not be valid. So which is that plane? This is that plane. So if you have like this reflection angle will be different. If it is this, there are n number of planes. But it is valid only when all the three rays are, or incident, reflected ray and normal, they are in same plane, then only it is valid. So, after that, now you go to, suppose you can see this is worked as an ideal mirror. Now it will follow laws of reflection. That is again total. Now if you go opposite, you will find when you go to rarer medium to denser medium, it goes towards normal. That also you can verify. And there is one more law. It is called law of reversibility of light. Suppose if I illuminate it from 10 degrees and if it is showing 12 degrees, if I go this side for 12 degrees, it should show 10 degrees. That also you can verify. Suppose you know the refractive index of a pure liquid. Suppose honey or kerosene or petrol, whatever. And if you know the refractive index of that pure, you can verify it with this, and with that you can also verify the purity of the sample. So with this simple experiment, we can show most of the laws which are concerned with the refraction. And also, after critical angle, what is the reflection? And purity of the sample, Snell's law, all those things can be verified with this instrument. This is named as a gyroscope, total internal reflection observation scope. Many questions, in fact, just now there are questions, why should we go for fundamental research? And I always use this example, this total internal reflection. Why do we study? What is the use of studying total internal reflection? But now, if in fact, almost everybody is online, and now you can communicate anywhere in the world with anybody. You can send messages, you can send pictures, you can send voice, you can send anything without any material. That is possible because of optical fiber communication. And that is the use of fundamental research. In addition to that, some of you might have seen this. We are taught, in fact, I have another gadget which shows that light travels in straight line. We are taught that. But we used to tell traditionally that candle and all those things. But I have a demonstration which can, n number of students can see at a time, and that is handy. You can carry it anywhere easily. See, although we are taught that light travels in straight line, this is like a wire. Now, this is a laser. Now, if I illuminate it here, you will find light it at this end also. It is there, no? Now the thing is how it flows from this tube and comes at the other end. This is again total internal reflection, and this is called endoscopy probe. And this endoscopy is such a useful thing. In earlier days, if you have some pain here, you have to cut open the thing, take the sample, go to the this diagnostics lab and all those things. Sometimes you may have to get admitted. But with this, it is hardly job of half an hour. No much pain, no loss of blood, and not much money compared to that. So most important is the human manpower, because if there's a cut open thing, you have to get admitted in a hospital for maybe 2-3 days. That all thing is relaxed because of this. This is what the importance of fundamental research. I have a copper coil and there is a flash. You can see there is no battery in this. Many times students suspect that there is some कुछ तो चालाकी कर रहे हैं, हाथ चालाकी कुछ नहीं है. So I converted it into transparent tube. Now you can see this is again Faraday's law of magnetic induction, and this is how whatever is excluding solar power, whatever the power which you are using is generated in this way only. There is a generator, there are magnets, there are coils. The magnets are rotated and the coils will convert it into electrical energy. There is a magnet here. Just to suspend it in air, what I have done, I have put them in a, there are 3 magnets in this, both of these. There is a magnet here, there is another magnet at the center, and then another magnet at the top. And I have put them in a repulsive mode, in that the poles are same. So it is suspended, and now just see when I move. But if I move it like this, it will not. There, the picture, that equation comes in picture. E is equal to minus d phi by dt. This rate is relative, motion is important. If they are both are moving in same velocity or same speed, you will not get. So that equation is very important. That rate is important. If you see, if I move it fast, then it will be more bright and it will glow. Similarly, this also, if I move it fast, it will be brighter. And again, if you see it very carefully, this is not at the center. There are some you can have the forces, gravitational force plus magnetic repulsion. and this way it is only gravitational force. So this is the addition of forces, so it is more, it is attracting to this side. See, I have a 1 meter long aluminum pipe, and actually I am not going to dramatize this. Otherwise, each of these experiments can be shown with all dramatization and equation and graph and all those things for more than half an hour. But I just simply, otherwise you can take another piece like a magnet and just drop it. It takes less than half second. But this, you see, if I drop it, it will take longer time. Okay. In fact, you can have mobile and measure the time. Now, I have another tube which is of same length, but this will take comparatively less time, and this will take further less time. Why? Because this is again based on Faraday's law and Lenz's law. When I drop it, because of gravity, it comes down, and there is a change in magnetic flux. When there is a change in magnetic flux, EMF is generated, and because of that, and Lenz's law said it will oppose the original change. So when it opposes, the magnet stops momentarily. When it stops, again gravity comes in picture, it pulls down. When it pulls down, again magnetic field is changed, so EMF is generated. Again it stops. So it takes longer time than normal free fall. And as the diameter increases, the pole gap also increases. So less the pole gap, stronger the force, so that you can verify. But in addition to that, there is another experiment I have developed. See, here there is a copper tube and here is an aluminum tube, and if I drop this from this, you will find there are pins here. They will move. When this magnet passes from this particular pin, it will move, and you can have a stopwatch and see how much time it takes to travel this 10 centimeter distance. And when you take the event, you will find after certain distance, the distance time taken for traveling the distance will be same. That will show that it acquires uniform terminal velocity. हम लोग जो पैराशूट से जब आते हैं ना, तो जब मिस attraction force and repulsive force they are same, so effective acceleration is zero. That you can how terminal velocity works, that you can verify with this simple demonstration. See, I have power supply here, DC power supply. Now, this is simple copper coil. Just see what I am doing. In fact, I can demonstrate Armsted's law, Fleming's left-hand rule, all those things can be, but it needs little closer observation. Just see what I am doing. I will just give supply, and on this, if I put this, you will find it's a motor. It's the how DC motor works. You can demonstrate very easily. Now you can change the polarity, you can change the polarity of magnet, you can change the number of turns, you can change the gauge of the wire, you can change the voltage, all those variations you can show. But with this, students can understand very easily how DC motor works. Here, I have a very simple arrangement. See, this is like a simple pendulum. it oscillates, and we know that period is T is equal to 2 pi under root L by G, and it is independent of mass, it is only dependent of under root of L. All those things you can explain with this. But you see, it can freely oscillate. Now what I am doing, I will just put this below this. You just see. Now if I put it just 2 or 3 oscillations, it will stop. This is because, again, eddy currents are generated in this container. I have a very strong magnet. When it's oscillating like this, it oscillates naturally. But when I keep this aluminum sheet here, that eddy currents are generated and it opposes the motion of the this. Now, for the same stand, I have a hammer and a wooden plank. Now, if I have to balance it, you just see what I do. Now the question is, where is center of mass of this integrated assembly? If you go to reactor hall, you will find there are many shieldings, and many of them are not of a regular geometric shape. And when they have to lift them, no, they have to, those people who do that, although we feel that they are not much qualified, but they do it very systematically, and they know where exactly to put that support. Where they should be suspended. Otherwise, if the mass distribution is not uniform, it will tilt anywhere. But they are expert in handling the heavy things, and they know. So now, this is also not a uniform mass distribution. So, where could be the center of mass of this? Okay. So when I come to center of mass, there are many experiments, but I always try to show this. Most of you may be aware there is some building like this, and it's called Tower of Pisa, and it is tilted. Okay, but when that tilt goes beyond certain limit, it will fall. What they have done, that remedy what they have done, that is more important. What they have done, they have broadened the base. By broadening base, what they did is center of mass is come down, because what decides the balance? It is the perpendicular drawn from the center of mass has to be within the base area. Then only any object will get balanced. So they have broadened the base. At the same time, they have poured some lead in the base. So mass also increased. So effectively, center of mass has shifted down. And now, if it is so, now even if you tilt it like this, it will not fall, because base is broad. There are many demonstrations on this. See this. This plank, if I make it stand like this, it will not. And this bottle also, if I keep it like this, you see, it's not balancing. But just if I move it little bit, it will balance. And that is almost horizontal. That is because the combined center of mass of this is above this base. Then only it will balance. Otherwise, it will not. And the best example is the calendar which we put our walls, no? That is the best way of center of mass. In fact, when we talk, when we walk, while walking also we are using, while getting up from the chair, we are using center of mass. But we are not aware. Everything, every action we do, there is the physics. Okay. I will continue like this, but you can tell me any time, I will stop that time. See, there are, I am very more, this you can continue for 2 hours, I am very sure. Okay. See, I have this pipe, and this is the uniform mass distribution. So if I bring like this, it will come at the center, and it will get balanced. Now, if I take this and this, their masses will be same or different? Will it be same or different? Alright, you can give a wrong answer. How does it matter? I'm not going to judge you. Huh? The material is same, length is same, mass distribution is same. So, no, both are hollow. Nothing inside. I'm not here to cheat you. I'm going to show, actually, I avoided that, but I will show you. See, scientific way of cheating, this material, what is it? Huh? It's not copper actually. I will show you. People, they use their scientific techniques. This is magnet. This is scientific cheating. See, this is aluminium and the mass distribution is same. So, if you take this, you will find the mass of this and mass of this both are same. But my actual experiment is this. Now, I have another attachment. Now, if I try to balance this, you will find it comes somewhere here. Now the question is, will the mass of this and mass of this will same? होना चाहिए नहीं होना चाहिए? अरे गलत हो तो भी जवाब दो ना, क्या प्रॉब्लम है? नहीं? होना?
Center of mass will be different, but the mass.
Mass of this and मेरा सवाल है ना वही बोलो, एक जैसा होगा या नहीं होगा? होगा? इसका मास और इसका मास एक जैसा होगा? So okay. Somebody is not agreeing with this. How many of you do not agree that masses will not be same? हाथ ऊपर करो, आप लोग लोकसभा जैसे करेंगे। हाँ, masses same हो गए। हाँ, पहले जैसे masses same हो गए, ऐसा कितने लोगों को लगता है हाथ ऊपर करो? I'm not going to name anybody. Now masses same नहीं हो गए, ऐसा कितने लोगों को लगता है? Okay. Now I will show प्रत्यक्षम प्रमाण, जो चीज कर सकते हैं ना वो करके देखने का। देखो ये जो है, somebody can come and just see how much is the mass or weight. How much is it? Okay, 50 grams. Huh? Now I will show the same was this 50. Now I will put this. How much is it? 100 something. Now the question is, why it was balancing? It's not only center of mass. There is some difference in center of mass and center of gravity. Okay, and when you apply force to the center of mass, it will move in the direction of force. It will not rotate. At the same time, there is some law called law of moments. It's not just law of center of mass. It should follow the law of moments. So, center of mass of this into distance from this connection and center of mass of this and distance from that multiplication is L1 M1 D1 is equal to M2 D2. That has to be followed. It will not just like that. Okay. So I will go to the next thing. Okay, this is again actually, although it appears to be very simple. See, if you tell it to go down, it will go down. But if you do not, if you just, otherwise it will remain like this. Huh? So you just see it goes down. The question is, I am doing it in front of you only, so there is nothing that special. The question is why it is going down. And I am doing in front of you. I am putting my thumb here and all that you can observe. The question is, we are told or taught that when density is more, it will sink, and when density is less, it will float. Now, what is it that is changing the density of this object? Or we can say specific gravity and all those things, but very layman's language, what is the thing which is causing the change of density of this object? So pressure, how will it change? I will show you somewhat similar to that.
Stopping here.
And these are again our classic demonstrations. For ages together they are coming. See, there is a tube inside. When you say go down, it will go down. Okay. Again, I know what I am doing. I am pressing it. But the question is, when I press it, what is it that happens to change the density or specific gravity of the bottle? Why is it changing? Which volume? It is a closed container. So there is no way that air or water can enter or come out. Okay. There is another tube. It is opposite. When I press it, it will go up. Now you tell me what could be the reason. And again, see, you can learn upthrust of liquid, buoyancy, buoyant force, Archimedes principle, density, all those things you can learn with this. And how much is cost? No cost. It is almost zero cost. But you should develop, students or teachers should develop the habit of using such materials which are available in their surrounding. And students should feel that the moment he goes home, he starts searching for bottles and tubes. That is the success, or that is the your gift. That's what you should get. Otherwise, if you just teach something and once they leave the class, they forget, that is not your success. I will come to the next demonstration. Okay, I forgot to tell about this. No, where is the center of mass of this? See, now if I shift it a little bit here, you see. Still it is balancing. But after I cross certain limit, it will not be able to balance it because it is exactly above, and I can prove that. I have a small hole here. I can show that center of mass is exactly, it is above this. I have put light here. So when the support is exactly above, it gets balanced. Now, okay, since before yesterday you are talking about elastic, inelastic, all this. Now I will just show you, you have to answer. And even if it is wrong, I don't mind. Okay, I will take one ball, release it. Okay, now I will take two balls, and all of you know that two balls will go. My question is, why one ball will go double the distance? Why not?
Energy of the.
If I take two balls will go. If I take three balls, the middle one will immediately change its role. Why? Now, if I take, even if I suppose, if I take two from this side and one from this side, you just see. Now, if I do like this, if I take one, center ball is stationary. Now, if I take both simultaneously, now if I do like this, and each of these has different meaning and different scientific explanation. As I told, it will take more than class to explain that. Now, suppose if I take like this, stop and hit and stop, means it hits and stops. Why?
Total transfer of energy.
Total transfer of, it is the 100% transfer, that is called elastic collision. Now the question is, now if I collide it like this, it is same case like this. See, I have a collection of many toys and I teach science from them. We should have a habit of explaining this. Whatever the material which you have should be used as a teaching aid. Now, I ask the question, why they stops? Why?
Loss of the
Loss of
energy
energy. How they lose the energy?
in the form of sound and vibration motion.
In the form of
Sound and vibrational motion.
sound and vibration. Okay. Just to save the time.
Gravity.
There are three reasons it loses energy. First is you listen some sound. Second is there is a viscous air drag. उसको आग नीचे दूर जाने के लिए वो वापस करता है. And there is one more thing. When any two objects collide on each other, it generates heat. So there is a thermal component there. So in every collision, it will lose that. So the question is now. Suppose I made some arrangement, I put this in some vacuum chamber. So, will it continue forever or it will stop?
If it is perfectly vacuum, then it will continue.
It will continue forever? Okay. Let me tell you, it will not continue because although sound, you will not be here, it will create sound. Thermal energy will also go. Only thing is that it will take longer time to stop. Now, I will come to the next. This is the modified version of. Again, I am telling. Although it is called Newton's cradle, its name is Newton's cradle, but it is not invented by Sir Isaac Newton. Somebody else has invented. Somebody else has named it, and you can Google. All those details are there. I will not waste my time in this. Now, see, I have modified it for something else. Now I have to show inelastic scattering. So when the masses are not equal, it will not, the scenario will be different. Now, if heavy mass comes and hit the less mass, you can find that it carries, it continues, and that small one also it goes. It's like a carom board. Carom board is sometimes if you hit that coin, then coin goes in pocket, at the same time striker also goes in pocket. Because why?
Mass difference.
It's the mass. It is inelastic scattering. The mass matters. Mass of striker is almost 15 to 18 grams. And mass of coin is hardly 5 to 6 grams. So, after hitting, coin will go, but mass, because of mass, its momentum is also more. So, it continues in that direction. But if opposite happens, what will happen? That bigger one, see, it's very good example of accidents. If you see the road accident, that small vehicle or the one which is comparatively light, it will be thrown off far distance. But heavy one will not go far out because its momentum is more. And there are many, you might have played marbles during your childhood. The bigger marble, it is called hunter. That hunter, it will not go far out. If you correlate whatever you teach or whatever you learn in your classroom, if you correlate with their day-to-day experience, they understand it much better. Are you able to see something? What is it? You can switch off light for some time. आपको क्या दिखता है? Okay, you shift this first. How does it change? What is it that you are seeing? Huh? Split. Why it is splitting? And you will find that there is a particular order of colors and distance also matters. If I change the sample to detector distance, then it will change. So can you correlate with what you listened since day before yesterday? Is it something to do with that? This film, although it appears as a simple film, it is a diffraction grating, and it's 1 millimeter. There are thousands grids, slits. So what you are seeing is actually diffraction pattern of light. लेकिन colors अलग-अलग दिख रहे हैं. And now if I just make the slit very sharp, you will find it's more clear. Can you see that? Now, just let it be off light. I will show you another demonstration, which is again very interesting demonstration. See, most of the laws of optics are applicable in neutron scattering and all that. So you should have command on optics also. See, what is it you are seeing? How many bulbs are there? See, I have only one bulb, and you can see the distance. Okay. Now, what I am doing, I will just put this bulb here, and you can see how many bulbs you are seeing. This particular glass is called semi-transparent glass, and this is normal mirror. You can see this is normal mirror. So when I keep this in front of this, you will find how many bulbs are there, how many images are there, and you know that formula. When you have two plane mirrors, number of images is equal to 360 divided by theta minus 1 and integer part of that, all those things. Now, question is, how much is the angle between these two mirrors? Particularly students, I expect that you should reply. And again I am telling, even if it is wrong, doesn't matter. How much is the angle? Huh? Let students respond. How much is the angle? Please. How much is the angle between these two mirrors? Result is in front of you, so you can back calculate it. Huh? They are parallel, so how much is the angle? Huh? 0. Now you put that value in your formula, 360 divided by 0 minus 1. So what should be the result? Huh? Huh? 360 divided by 0 is correct. How come? I am being taught wrong mathematics. 360 divided by 0, how much is it? Huh? Then you are finding something defined. So what is wrong? Okay, to save time, again here comes the concept of limit and integration. See, we are taught in 11, since 11th standard, we are taught that the limit x tends to infinity, x tends to 0, this, that. Means x is tending to 0, but it's not 0. Its value is not 0. It is approaching very close to 0, but it's not 0. That's the reason the distance, means angle between these two mirrors is close to 0. That means it's very small value. So when you divide by some number, by very small number, you get large number. And that large number is this number of images. This is how actually you should be able to correlate the thing. Otherwise, that formula, you can make it by heart and write something, you may get marks, you may get admission somewhere. But when it comes to apply that, it becomes like, I always tell the example that we are taught that when you are walking on the road, you should follow left or right. In civics, we are told no. आपको 5th, 6th, 7th क्लास में पढ़ाया जाता है कि रास्ते में चलते समय कौन से रास्ते से चलने का, कौन से बाजू से चलने का, राइट और लेफ्ट.
चलते हो राइट, पेडेस्ट्रियन राइट.
हम लोग बाहर जाते हैं तो कौन से रास्ते से चलते हैं? हाँ, we don't follow that. वो पढ़ाया तो गया, हम लोग ने लिखा, मार्क मिल गए बस. वो ऐसा साइंस का मत करो. It don't make civic science as a civic. Okay, I will move one more demonstration and I will stop. Of course, there are few more. I will take, okay, 2. You can switch on the lights. So this particular demonstration we used to show for, see, if I just leave it like this, it is horizontal. Now if I start spinning it, you will find it's vertical. So the question is why it is stands in vertical. As long as it is spinning, it will stand in vertical position. Why? It is well. I don't want it to be one way. I want you people to respond. देखो मजा नहीं आता है
shifting of moment of inertia.
Shifting of moment of inertia. Why it should shift?
Because you are rotating, so
After rotating, what happens? Physics wise, you talk in terms of physics.
center of mass is shift.
So when any object spins or rotates, there is something called angular momentum. And angular momentum is a vector quantity. And vector quantity has a magnitude and direction. So when it is spinning, it tries to maintain its direction. Okay, now you see, it is in this way. At the same time, it is spinning around the rope also. Now if I change the direction, instead of towards me, if I spin it like this, its direction of spinning around the rope will also change. And as speed goes down, it will become horizontal, because when it is no more spinning, there is no more angular momentum. We used to carry this whole thing, but nowadays we carry this one. ये आपको मालूम है ना, fidget spinner. With this you can explain many concepts of science. वो torque कैसा generate होता है वो. See now if I spin this, okay, so it is principle is again same. So and if it is spinning and if you try to change the direction, it will give jerk, because you are changing the direction deliberately. So it will oppose for that. So that needs a very frictionless rotating table. You can demonstrate that also. Okay, so I will one more demonstration which I have. Okay, I would like where is Akshay? Akshay is there? Please come here. So you will know why I called Akshay. Huh? Okay, you can stand there. What you have to do, you have to just hold these two probes in your both the hands. Okay, and you can test them. Okay, see what I am doing. Okay, nothing to worry. Huh? There is a power supply. I am just connecting a power supply. DC, huh? And that to very low voltage. Now just see what I am doing. I have a small transformer here, and to that primary I am giving this 6 volts. Okay, it's very 6 volts only, and current is very low, so you don't have to worry. Okay. Now
कुछ नहीं होगा तब भी गिर जाओगे. थोड़ा आगे आ जाओ.
अभी क्या करना है? देखो, I have a potential divider arrangement, so I can reduce the voltage. Okay. See, I have numbered it.
Short circuit होगा.
You just tell me. Do you feel something? What do you feel? Little jerk. हाँ? कहाँ तक लगता है? उंगलियों तक आगे. Okay. थोड़ा आगे लगता है. I will just increase it little bit. Huh? Okay. Now I will increase it little bit.
ये भी एक थर्मोमीटर है, वाइब्रेशन थर्मोमीटर.
बढ़ गया. Now I will give you jump. Unbearable. Okay, now I will not go to that. Okay, now a few more students can come, 5, 6, 7, maybe, please. And you have a human chain. just see what happens. You just put your hands together. One of experiment. You can face the audience. एक आप इधर आइए, and you stand in between. आइए आप क्यों डरते हो ना? ऐसा संकोच क्यों है ना? कुछ नहीं होगा, मैं हूँ ना. उनको फेस द ऑडियंस, ऐसा खड़ा हो जाइए, ऐसा. हाँ हाथ को करना है. नहीं आप लास्ट यू आर एक्सट्रीम, अंदर आइए, बाकी लोग अंदर. सर्किट कंप्लीट करना है. इधर यू फेस, हाँ उनके तरफ फेस कीजिए. हाँ बस. हाँ अभी पकड़ो. अभी उनका सबका रिफ्लेक्स देखना है. ओके. हाँ अभी सबका रिफ्लेक्स देखना है ना. और हु इज मोर सेंसिटिव. You can make out who is more sensitive for electrical pulse. See. So you are out. Please. अभी आप उनके हाथ पकड़ो. Now we'll see again. Okay, अब बाहर जाइए. प्रथमेश. अभी देखते हैं. ओके. Okay, दोनों पे actually they are still resisting that. So basically, okay, thank you. Actually, this demonstration is nothing but how for physiotherapy, how it is used. Normally, when this Sachin Tendulkar was suffering from the tennis elbow, so they use this type of treatment to just activate the cells which are about to die. So that way they are using this for medical purpose. So with one more demonstration, I will stop. I will come ahead. Again, Akshay, please come. You can bring your bag. भारी है? कुछ भी नहीं ना? I will make it heavy. Don't worry. Okay. I have to pour more things. Okay. We'll add little bit. We just open and put these two bottles. So in between, if you become thirsty, you can use that water. Now, if I give this tea, and if I'm told, you are told that you can take this and go. It's comfortable, no problem. Okay. Now, you have to follow some rules. You have to hold it like this. Okay. Your shoulder, hand, and this pipe should be in same plane. It should not be like this. ऐसा कुछ नहीं है. एक ही plane. अभी okay. Are you comfortable? Okay. Now just see. Any problem? No problem. Okay. You full strength, huh? Okay. Any problem? Right? Now, what? Okay, you can hold it here also. Don't allow it to slip. Otherwise, I will remove some weight. I think it is a little beyond the. Yeah. Okay. Now you let it be like this. Okay. Are you comfortable with this? Okay. Now we'll just shift it a little bit. Okay? No issue. I'm not adding anything, but still he's not able to hold it. Now the question is why?
Shifting.
हाँ?
Shifting.
टॉर्क बढ़ता है, मतलब क्या होता है? See, if you are okay, thank you. Just have a seat. Yeah. See, if you are told to open this bottle with one finger, will you be able to do that? Will you be able to do that? No, because to open the bottle or open the water tap, you need to have two fingers because you need to apply two forces which are opposite in direction. Right from our childhood, we are doing that, but we don't know what is torque. For rotation of any object, you need to have torque. Without torque, no object will spin or rotate. See, when Akshay was holding it like this, gravity was pulling it down, and Akshay was applying force in this direction. So, when I shifted, that is torque. When perpendicular distance between the two forces increases, the magnitude of torque gets multiplied by that much distance. So that is how Actually, this particular experiment, as Dr. Babu told, I keep on going to different places. Once, about 16 years back, I was called at IIT Kanpur, and Professor H.C. Verma, Padma Shri H.C. Verma, he called me, and I showed many demonstrations like this. So one of them was this, and he also included this particular demonstration in his set, and now he has named this experiment as Joshi Jikadanda. Thank you very much. I'm sorry I have crossed the time limit, but once I start now, it's very difficult to control.